All right, so today we are going to learn a little bit about how to calculate beam loads. And in this tutorial, I'm going to walk you through the process. So this is an example of a partial roof floor framing plan. And this is the roof framing plan for the suburban high school in Chicago that you're going to be working on in the practice problem. There are a few things that you're going to want to be aware of. So these I's are the I-beams or columns in your floor framing plan. We also have these beams, which are these horizontal members here in red. We also know that the beam span or the length of the beam is 18 feet. We can see that specified here. And lastly, we also have these larger beams and longer beams. And we're actually going to refer to these as girders. And these girders are 20 feet in length. And this information is going to be super important as we move forward throughout this problem. So when you're calculating beam loads, it's a 5-step process. And I know that there's a lot of words here that are going to be pretty new to you that you've probably never heard of before. And those are tributary area, beam span, tributary width, beam uniform load, floor loading, dead load, live load, which you should remember from the load and load paths conversation we had earlier, and then putting it all together to figure out the uniform load. No need to write this all down now. I'm going to walk you through each step of the process here. So if we're looking at this girder on column 4, we want to know the area that the girder is responsible for supporting. We call this the design area or the tributary area. So this girder is responsible for carrying half the load to the next adjacent girder and half of the load to the next adjacent girder. And I know that the area isn't quite right, but you get the idea. So let's say we're looking at this beam right here, and we want to figure out how much weight this beam is responsible for. The first thing that we're going to want to do is to figure out what the tributary area is. And the tributary area is going to be the area that the beam is responsible for carrying, which is going to be half of the distance to the next beam on one side and half of the distance to the next beam on the other side. So this entire area highlighted in yellow is the area that that particular beam is responsible for. If we look at this a little bit closer, we can see that this beam is responsible for 3 feet 4 inches this way and 3 feet 4 inches this way. The reason why I know that is because the distance between each one of these beams is 6 feet 8 inches. So to find the tributary area, or the total area in square feet that this beam is responsible for, we want to multiply the tributary width, so a total of 6 feet 8 inches, times the span of the beam of 18 feet, which we'll talk about more in just a second. So to figure out the area that this beam is responsible for, which is the tributary area, we're going to multiply, again, 18 feet times 6 feet 8 inches, which is our tributary width. We want to make sure that we convert that to decimal feet, and we get a total area of 120 square feet. We're going to be using this information in the next part of the problem. For the next part of the problem, we need to figure out what the beam uniform load is. That is, how much weight is actually being applied to the beam. So we want to figure out the floor loading in pounds per square foot and multiply that by our tributary width. Remember, our 6 feet 8 inches is our tributary width, which is 3 feet 4 inches in this direction and 3 feet 4 inches in this direction. So in a typical beam loading problem, you're going to see some kind of statement like this. So assume that the floor system must support its own weight of 40 pounds per square feet, which is a dead load, and a live load of 100 pounds per square foot. So what is a uniform load applied to the beam? So all we need to do in this situation is add up our dead load plus our live load to get a total beam load of 140 pounds per square foot. Now, to figure out the uniform load, we want to make sure that we're multiplying the total floor load times the tributary width to figure out how many pounds per linear foot that beam is going to be responsible for. So if we take our floor load of 140 pounds per square foot, or PSF, as we see here, and multiply that by our tributary width of 6.67 feet, we're going to get 934 pounds per linear foot. Now, the reason why it changes to linear feet is because we're actually canceling out one of the feet here. So we're left with pounds per foot or pounds per linear foot. Either one works. So all of that work has gotten us to this point of finding out that our beam is responsible for carrying 934 pounds per linear foot. Our next step is to figure out what type of beam to select, and this is where you're going to be looking at a table to figure out the different types of beams that you can use in this project. So I'm going to hand you off to the next tutorial, and that's going to show you how to look at the table to select a proper beam for your project.